Oh, thank you for coming this session in person and online. Let's start. I'd like to make a presentation developing Wear OS apps with Jetpack Compose. We can use Jetpack Compose for developing Wear OS apps. As you know, Jetpack Compose is a very useful and powerful toolkit. It makes us accelerate our developing speed. At this session, I'd like to talk about how to dive into Wear OS apps world with Jetpack Compose. Okay, let me introduce myself shortly. I'm Kenichi Kambara from Tokyo, Japan. I'm so happy to be here with you in person. I work at NTT Technocross. NTT is a telecommunication company in Japan, and I'm working as a technology evangelist. And my work is technical support for developing mobile and wearable apps, and speeches like these events and writing these books. But unfortunately, these books are written in Japanese. Yeah, and my Twitter account is Droid. I'm happy you followed this account because after this session, I publish this material on Twitter. Okay, let's start. Personally, I've released many mobile and wearable apps. Here is one of my apps. It's called Sekai Phone. Sekai is Japanese word. It means world in English. Phone is a phone, a word phone. It's a real-time speech translation. If you speak in Italy, I can hear in Japanese or English or any other words. It supports 100 languages. And it supports Android, iOS, and Wear OS. Based on my development experiences, I like to share more details. Here is today's agenda. At first, I'm going to introduce Wear OS history and features. After that, I like to introduce some latest topics. Next, today's main topic, Compose for Wear OS, such as fundamentals, how to get started Wear OS apps development, and how to create practical Wear OS apps. Okay, here is a history of Wear OS. As you know, Wear OS was started as Android Wear in 2014. It's just 8 years ago. 4 years later, it was rebranded as Wear OS. After that, day by day, some attractive features were added into Wear OS. And as you know, Pixel Watch was announced. And today, just before this session, made by Google, announced Google official channel has announced more details about Pixel Watch. We can get a Pixel Watch maybe this month, and I'm so excited. So I'd like to get one as soon as possible. Wear OS is based on Android. It's very similar to regular Android for mobile, but there are some differences. Here are some Wear OS features. First feature is overlay. It's just like apps on mobile. We can use apps on our list like mobile devices. Second one is a notification. It's very similar to ones on mobiles. We can easily confirm some updates such as got a new message from my boss, oh my god, or some happy updates from my friends on our list without checking my smartphone. Third one is complication. It's just like a home screen widget on mobile Android device. On the watch face, we can place some kind of useful information such as today's step count or weather or temperature and so on. This is very useful feature, and these mini information are called complication. And fourth one is tile. It's one of my favorite feature of Wear OS. As you know, wearable device screen size is very small compared to a regular smartphone. Sometimes it's really hard for us to launch wearable apps from my smartwatch. It's really complicated. But by using this feature, we can easily confirm this information, such as today's weather or today's my plan or any other thing without launching apps from my smartphones. From my wearable devices. Okay. Let's move to the next topic. At this session, I'd like to focus on this overlay, how to create all these overlay apps with Jetpack Compose. Okay, before that, at first, on this year's Google I/O, many updates were announced about this relationship with Fitbit, and in more countries, we'll be able to use payment with Wear OS device. Also, Health Connect was announced. It's a very useful toolkit when we develop the Wear OS apps for the health. Finally, it's a new use case for collaborating with home appliances such as lighting or air conditioners or any other home appliances. By using this feature, we can control this device by our device, our smartphone, our smartwatches. At the time, it was announced two main developer features about Wear OS. First one is Compose for Wear OS. At this Google I/O, Wear OS became beta version, and for this is very useful open source project by Google. It provides Wear OS apps developers many kind of useful library, such as developing these features. I'll talk about more details later. Okay, after Google I/O, on this July, Wear OS 1.0 has been released. It's now stable version. At any time, we can start developing Wear OS apps with Jetpack Compose. Let's move on to the main topic, Compose for Wear OS fundamentals. As I said at first, there are some similarities and differences between Wear OS and mobile. When we develop Wear OS apps, we have to take care about all these points. Here is a code example for creating a button with Jetpack Compose. At first line, we define this composable annotation and calling button compose at the third line. And it includes some properties such as modifier, on-click event, and enable status. Additionally, I add an icon composable like this. This is a microphone icon. I can use this material icon library for these wearable OS app applications. As you see, almost it's very similar to a mobile composable. Then, what is the difference? I'd like to talk about this. Okay, first one is here. The most big difference is user interface and user experience. There are some specific input components. It's optimized for the list. Even if the screen is very small, we can easily control our apps by using these components. The same way, progress indicator, dialogues, page indicator, and navigation. There are some differences, but it's almost same. But if we, when we develop Wear OS apps, we have to take care about these differences and behaviors. Okay, next, furthermore, there is extremely important characteristic of Wear OS. It's here. In Wear OS world, there are three kinds of shapes, round, rectangular, and square. When we develop apps, we have to take care of shapes. If we don't take care enough, our screen would not be shown as we expected. So taking care of these shapes is very important. Also, the provided classes are almost same, but there are some differences. Differences are here. For developing Wear OS apps, we should use Android X Wear.compose library. But on the other hand, for developing mobile apps, we should use Android X Compose material library. It's a little different package. And as the same way, navigation to develop Wear OS apps, we should use navigation Wear OS library. And foundation is the same, but for a Wear OS device, I can use some extra library as a foundation class. Okay, here is one more example. For Wear OS, it's recommended to use this Wear OS package Android X Wear.compose library. By using this library, we can show this Wear OS user interface. On the other hand, for mobile, it's recommended to use this mobile material library. It's because we can provide a better user interface and user experience to our user. So it's very important point. I show some more example of Compose for Wear OS. Here is a cheap example. It's very useful component. When we develop Wear OS apps, I think it will be used to develop Wear OS apps. It's very useful component. Okay, here's the example. Defining a composable annotation and calling a chip component, and it includes two properties, a modifier and icon. And icon is like this, includes this icon, and chip component can include two text, primary text and secondary text, like this, Japan, Tokyo, and on-click event. Okay, like this, we can implement this composable. Okay, next, it's very useful library for showing this confirmation. This is a confirmation example. I'm explaining about that. First line, composable annotation, and third line, it's defining a variable is showed. It means we have showed or not, and if we don't show this confirmation, we have to show this confirmation, and it includes two properties, on timeout and icon. For on timeout, after desired time passes, this line will be executed. And for this icon properties, the same way, and I can add some text like this. Okay, by the way, I'm introducing HoloGist. As I said before, it's very useful library. It's just like a accompanist on mobile. It assists us to develop Wear OS apps efficiently. It contains this audio and media UI library and some specific input components. It's very useful. Okay, let's move to next step. How to get started. Compose for Wear OS. At first, about Wear OS or development on environment. For Android Studio, in my opinion, I recommend to use Android Studio Electric Eel version. It's because it has an attractive feature for developing Wear OS apps. And it's now on beta version. But if you prefer to a more stable version, the Dolphin is also okay. But if you try using some more advanced features, try Flamingo. After that, we are going to create a Wear OS or AVD, Android virtual device, for testing our apps without any real device. Happily, now this system image supports Apple Silicon CPU in addition to Intel CPU. So if you are an Apple Silicon MacBook user, you can start Wear OS apps development. Okay, here are some templates for Wear OS apps. But if you'd like to create a project with Jetpack Compose, make sure to choose this project, empty Compose activity. It's because it includes some Jetpack Compose library. The rest of Wear OS project doesn't include Jetpack Compose. So make sure to use this one. After completing the project creation, this screen will be shown. Okay, opening the main activity.kotlin file. And for the first time, I have to build tapping this button. After waiting, return this Wear OS screen will be shown. On the right side, a split button, by pushing this button, we can show on and off a preview screen. It's very same to mobile. And here is one tip. This feature will make us improve our developing speed. It's called Live Edit. By enabling this feature, we can accelerate developing Wear OS apps with Jetpack Compose. So I strongly recommend you should enable this feature. Okay, let's try a live demo. How to make a simple Wear OS UI. Okay, this is just a very simple Wear OS UI. It just includes Hello Wear OS. It's very simple, but I'd like to add some contents onto this screen. Okay, deleting this text, the previous screen will be shown at the same time. And Droidcon Italy 2022. And changing the color from primary to this time, okay, secondary color. Okay, it will be shown like this. And adding one icon on this text. Okay, this time I like to add icon and image vector icons dot default dot Android and adding a content description. Okay, like this, we can develop a Wear OS screen like this. Okay, I'm going to add an explanation about a preview feature. When we use Wear OS Compose preview, we have to add this preview annotation like this. Devices dot Wear OS small round. It means the shape of Wear OS device. And show system UI equal to. It's like the same to a mobile Jetpack Compose. Okay, to enable Wear OS preview, we have to define this preview annotation. As I explained before, there are some kind of shapes in Wear OS world. By doing that, we can easily confirm our screen at the same time in these different kinds of shapes, like circular, rectangular, and square. It's very almost same device, Wear OS large round, Wear OS rect, Wear OS square, by defining these three code, we can confirm our screen at the same time. Okay, let's move to the advanced topic. How to make the practical wearables apps. I think it's the main topic of this session. Okay, it's just an example for a contacts app like this. Okay, as you see this screen, it doesn't look bad, but I think it doesn't look good. It's because it isn't optimized for the list. The code is here. This code includes a lazy column. It's similar to a mobile, and it includes a list header and some list component and chip component like this. Okay, it isn't good. So then we have to improve this non-good screen. How to make better UI for Wear OS? Let's improve this user interface. Okay, first improvement is here. Instead of using a lazy column, let's replace it to a scaling lazy column. By doing that, appropriate margin will be added between each chip. I think it looks better than before. And as closer to the edge, at the upper point, the chip should be smaller, little by little. It's closer, smaller by smaller. Yeah. And it looks a little better than before, but it's not still perfect. Okay, here are some points to improve this screen. Here are some points like this. When we provide Wear OS apps, we are requested to show the current time, because showing the current time is very important feature. It's Wear OS is a clock feature, so we have to show this current time. And second point is vignette. It means at the edge of screen, we have to add some blur like this. And the third point is position indicator. Sometimes our apps include these long lines. So we have to show our current position like this. How should I implement all these features on Wear OS? Okay, I'll explain. It's very simple. It's just using scaffold. Scaffold is very useful library. By using scaffold, instead of placing scaling lazy column directly, by adding scaffold on the top, and scaffold includes some properties, time text, vignette, and position indicator. By defining like this, we can implement these features like this. Time text includes if this state dot is a scrolling in progress, it means during scrolling, it doesn't show any time text. But if I stop scrolling, the current time will be shown like this. And a vignette is like this, and a position indicator like this. We can easily implement all this feature. Okay, by the way, this app contains only one screen. It's not practical. So let's add one detailed screen onto this app. Okay, I'll explain how to implement this new screen. It's very simple, like this. Let's define another composable function. It's just typical tip. It contains one column and like this. It includes some text composable, three my name and my phone number and my nation. like this. By defining this code, we can easily add this screen onto our app. But there is one important point. Furthermore, after tapping one of the chip, I like to show the detail screen. So it's a navigation feature. So I have to add this navigation feature onto this app. Okay, here is one implementation like mobile apps. It using some navigation libraries such as navhost controller and navhost. It's very similar to a mobile. By defining these codes, we can easily implement this navigation like this. And navhost must include this multiple composable screen like this. It's very simple. I have to modify some code on the detail screen to give the parameter for this function to give a navhost controller to like this. And on this on-click event, on nav controller navigate and to desired or detailed screen with argument and with index. Okay, but here is one problem. By doing that, we can implement this feature, but there is one problem. It means by checking my name, but I like to back to the previous screen, but these apps will be dismissed. It's a big problem. So I have to modify this problem. Okay, as I explained before, when we develop Wear OS apps, we are requested to use this Wear OS navigation library instead of a mobile navigation library. But it's very simple. By adding this code into our build.gradle and wear.compose compose navigation library, we can easily use this navigation library. Okay, this is next code, fun.screen navigation. Okay, instead of regular host controller, I should use remember swipe dismiss nav controller. And instead of using nav host, we should use swipe dismissible nav host. By modifying this like this, we can implement like this. After choosing my name, choosing Ken, and I like to swipe to be dismissed, I can come back to the previous screen. Okay, that's all. We can implement like this by using Wear OS library. Okay, next step, I'd like to explain some example about how to run Wear OS apps development. Here is one tip, is code labs. As you may know, there are a lot of useful code labs contents. And some contents are related to Wear OS. One of them are Compose for Wear OS code labs. Code labs includes some practical OS apps development. So by using this code labs, we can learn a lot how to develop Wear OS apps with Jetpack Compose. And I'd like to recommend this second code. It's sample project. If you use Android Studio, you can easily try this sample code for Wear OS apps development by choosing import sample and inputting where we can find these two sample codes. Compose for Wear OS data and Compose for wearOS Advanced, like this. I'd like to explain a little about this project. First one, Compose for Wear Starter, like this. It's very simple, but it's optimized for the list, so we can learn how to be shown our Jetpack Compose into our emulator. And by using wearOS Advanced, I can learn a lot about wearOS apps development. Okay, there are some references. Google I/O contents includes some how to develop wearOS apps. And Jetpack Compose for wearOS is now 1.0. It's very useful article. And Hologist is also important. Okay, let's wrap up our session by using wearOS for Jetpack Compose. I can go future. And I think it's important to optimize for wearable device. It's because if we don't take care about wearOS specification and characteristic, we can't provide any good application. So it's very important how to optimize for wearable device. And let's expand wearOS world with making apps. I think it's very important point. Okay, let's create wearOS apps together and expand our wearOS world. Okay, thank you so much. Thank you for attending this session in person and online. Do you have some questions or comments? Thank you for attending.